Do you love fast cars, missiles, rockets, or my personal favorite, axe throwing? If you do, then this is the physics unit for you. We're going to study the motion of all these things with equations, with math. This is called kinematics, which I know is kind of a weird name, but trust me, it's pretty cool. In our last unit, we studied all of Newton's laws and learned about force, acceleration, and we're going to apply these ideas to track the motion of these objects. In this video, we'll introduce you to all the essential concepts to get you ready for this unit on kinematics. Let's learn. Let's begin by reviewing our lesson objectives for this introduction to Unit 3. We'll start by introducing kinematics in one dimension. Then we'll move on to slightly more complicated and much more relevant problems where we study kinematics in two dimensions. Kinematics actually ignores friction, so at the end of the unit we'll turn to friction and we'll introduce friction. Alright, well, as I've said, we'll start the unit by considering motion in just one direction or dimension, like running a race. Here all we really care about is the distance the runner has crossed and how long it took them. This sort of motion is the easiest to track. We'll be able to answer questions like, a runner runs at a speed of 6 miles per hour. How far will the runner have traveled in 4 hours? And to solve problems like this, we'll use what are called kinematic equations. Here's one that we could use to solve the problem just mentioned. It says the displacement final is equal to velocity times time plus the displacement initial. Now, you don't need to understand the details here now. We'll talk much more about this later. But that's the basic sort of equation we'll be using here. Now, all of this may have you wondering, what in the world is kinematics anyway? Great question. Well, kinematics is describing motion with mathematical equations. And once we've done that in one dimension, we'll build to more complicated circumstances. Like the motion of this hot liquid magma as it flies from the top of the volcano. Where will it land? Will it hit us? Now we care about both how far it travels, how long it takes, and what spot around the mountain it will hit. We'll be able to answer questions like this. I won't read it, but notice what we're doing is tracking the rock's motion as it flies out of a volcano. To solve problems like this, it's important for us to be able to split up velocity and displacement into multiple components. What do I mean? Well, take this basketball hoop as an example. Let's say the girl needs to throw the basketball 5 feet to get it to the hoop. Well, we can actually split this up into the distance that we need to throw to the ball to the right and the distance up. It sort of makes two legs of a triangle. If it needs to go 5 feet total to the hoop, that's the hypotenuse, then it needs to go 3 feet to the right and 4 feet up. We'll go through all the math you need to go between all of these different distances. Just like we can do this with distance, we can do it with velocity. If the basketball was thrown at 2.1 meters per second, we might want to know how fast is it traveling to the right and how fast is it traveling up, again making two sides of a triangle. We would call one of those the velocity in the x direction and the other the velocity in the y direction. Again, we'll go through this in much more detail in this unit. One important thing to realize about all of this tracking of motion with kinematics is that it neglects friction. Kinematics neglects friction. And that's why at the end of the unit, we'll actually study friction. Here's a case where friction's relevant, a super adorable picture of a dog pulling a kid on a sled. Frankly, I kind of wish I was that kid right now. Anyway, the dog is pulling, so there's a force from the dog. And the child resists that motion due to friction. There's a force of friction going the opposite direction that the dog is pulling. That type of friction is actually called kinetic friction. It's the friction force acting on an object in motion. Its opposite is static friction. That's the friction force acting on an object at rest. And you can kind of hear the word static as referring to still or not moving at all, right? Which is exactly what we're looking at when this man tries to push this boulder. He pushes on the boulder, but of course it doesn't move, and that's because there's a friction force opposing it. And it would be a static friction force. The last thing we'll do in this unit is we'll consider friction and motion on a slope like this, a skier riding down a hill. And in physics, we call a sloped surface an inclined plane. And the interesting thing about inclined planes is that once again, we need to split stuff up into its components. For example, let's take acceleration. The gravitational force on the skier is straight down. But we might want to know about the acceleration parallel to the surface. That's why it has those two little straight lines there. That would be the acceleration force driving the skier down the hill. That's what makes him go. Meanwhile, the other acceleration force we might think about is how gravity's holding him to the surface. That's called the perpendicular acceleration. And we can split it up using the triangle that is this inclined slope. Much more, again, that we'll get into as we go through this unit. Now, here's your chance to know if you've kept up with all the material we've discussed. Go ahead and pause the video and see if you can answer this. Here's your goal. Match the options in the answer bank below to the correct description. And you can use more than one answer here. First up, what's a sloped surface called? Well, we look at our answer bank and we see, an inclined plane. What is a resistive force on an object in motion? Well, a resistive force there is going to be friction, and because it's for an object in motion, it's going to be kinetic friction. What about a resistive force on an object at rest? Number 3 there. Well, that will be static friction. What is the study of motion with mathematical equations called? That is called kinematics. And then the last one, which has a number of answers, is these can be split up into components. And that's actually velocity, distance, and acceleration. And by components there, we just mean parts. It can be split up into different directions. Let's review what we've learned. First, we introduced kinematics in 1D. Remember, kinematics is studying motion with math. And we talked about tracking that in one dimension, like how far a runner has run. Then we introduced kinematics in 2 dimensions, where we saw that we could track something like a rock flying out of a volcano. And to do that sort of math, we're going to split up position, velocity, and acceleration into 2 separate components. And lastly, we introduced friction. We said that kinematics neglects friction, and so we end our unit by talking all about friction, both static friction, which is the friction force on something at rest, and kinetic friction, which is the friction force on something in motion. Hey, hey.